Thank you so much, Julie and David. We're now starting a really interesting segment looking at a number of imaging initiatives. Dan Boisvert from Biogen will kick us off with the first one focused on anonymization. Dan.
So, thanks, everyone. Let's see how I do this. Great, thanks. My name is Dan Boisvert. I'm a Senior Director and Head of Data Stewardship at Biogen. And I'm going to talk about unlocking imaging data sharing. So what we're talking about here is how do we as sponsor companies share imaging that we run in our clinical trials with external researchers. And I'm just going to talk about the process of what we're doing here. And you know, when we started working on this, I think, you know, we're in the modern era here, right? Like, it's 2025. We should be able to share images just like we share tabular. I feel like we've been sharing tabular data for forever. You said 8 years at Vivli, but it feels longer. And so then I go to my team and I'm like, well, why are we not doing this? And they very quickly say, Dan, it's complicated. It's really, really complicated. So I want to give you just a high-level overview of why it's complicated. So what I have up here is a movie kind of showing what an MRI is, right? So you go into the doctor, you have an MRI. It's not a picture, right? It looks through your head in these like slices, right? So if you're for one patient, you'd have a whole sequence of images. And then that's given to us in what's called a DICOM file. And here I have a chest x-ray because it's all I could find in the open community. But you'd find identifiable information all over it, right? So you could see name, you could see date of birth, you could see like the hospital where it's at. And that's all like within the image itself. So to anonymize this, obviously we have to get rid of all of that information. So that's complicated by itself. Then with a DICOM comes a header file. So this is on the right here. It's more like a tabular format of data, and again, contains subject number, patient name, age, ethnicity, things like that would be in there. So, okay, so you have to get rid of all of that too. Okay, so right now, okay, that's complicated. Of course, it doesn't stop there. There's this idea of facial reconstruction. So if you have all of these slices of your head in an MRI, what you can do fairly normally now is reconstruct the face in 3D. And so what you could see on the bottom is the reconstructed face. And maybe not surprisingly to you guys, but the face is a direct identifier, at least according to HIPAA. So what we're looking at is these. We're going to account for all of these in our anonymization. But I want to offer up, too, that there's this idea of a brain print. And there are other new ideas coming out of here. But the thought with a brain print is that the actual curves of your brain are unique to you. But it's not like, you know, you go to a dinner party and you leave your brain print everywhere. That's not what's happening. But you know, you could imagine, you know, bring a huge database of faces that could identify brain print to face, and then all of a sudden you have that direct connection. I mentioned that just because it's an evolving field, and we always have to just make, and I think David was saying this too, you just have to make like a pragmatic decision at some point, just so you can go forward. So some key considerations here as we do this. This is not the public release of images, and I think if we were to release them publicly, it'd be a lot harder because there would be these things of hidden biomarkers, brain print, and things. You know, Vivli really helps us out here a lot. Controlled storage, controlled AI ML capabilities. You can't use this data to feed a model that can be taken outside. But also it's going to be point in time where we say, you know, this is what we're calling anonymized enough for now, but there are going to be evolving capabilities and we're just going to have to keep up with it over time. When we went to do this, it's very hard to do these things by yourself. You know, we could think what we know as anonymization, what we think it looks like, but we only know what we know. So it's really helpful to have some partners out here, and Vivli did a great job getting us great partners from Sanofi, Pfizer, and now we have someone from Boehringer Ingelheim also helping us out on this. It's after lunch, and I think we know each other a little bit, so I'll give you a little funny story about how collaborations happen. So I took over this group in 2024, I think. And then, you know how things happen at biopharmaceutical companies. Things are a little bit messy, and I forgot to pay the Vivli invoice. for like a little too long. And eventually Julie reaches out. It's like, oh, hey, you want to pay your invoice? And by the way, we have a conference and we're meeting for dinner if you'd like to come. And I was like, oh, I feel so bad for not paying this thing, so I better go for dinner. I go for dinner, sit at a random table, and next to me is Rutha, who's like the head of product for Vivly, saying, oh, we're thinking about sharing images on Vivly. I was like, oh, wow, well, my team just has images. Maybe there's something that we can work on together there. So that's how it starts. We get together in Q1, start a collaboration on this. And I've worked on a lot of these cross-company initiatives. I know sometimes they're hard to get off the ground. So what I asked my team to say, well, let's just write down what we think our position is on the right level of anonymization. We have a lot of skill set in my team. Let's just say what we think, and then it's always easier to critique than to create. So we could bring that to the team and have them, and then that's exactly what we did. We drafted the position on it. We had it reviewed by our collaborators. We reached out to different imaging vendors, different people in the industry, trying to work with Fuse on reviewing it too. But we're trying to finalize this and release it by the end of this year. So it will be a short project that we did in order to get here. In terms of the guideline, and now I am not the imaging expert, I have my imaging expert with me. He did come. If there are deep technical questions, I'll point them over there. But I want to give an idea about what the guideline looks like, or what our recommendation looks like, and the completeness of it. So, within the DICOM header, there are many different kinds of tags. There are standard tags, private tags, nested sequences. We want to try to maintain as much data utility as we can, but we have to do some reasonableness about what we can exclude or not. So private tags, these are things that come from the machine itself. Oftentimes they have encoded values, so it might just look like kind of gibberish, but if you decoded it, it would be patient name or something like that, like really directly identifying information. So that's too much risk for us, so we just like to exclude those. They're not typically used in analysis. Kind of go down into this, get embedded documents or the DICOM overlay stuff. What happens is in the review of images, people will take a screenshot and then maybe annotate some stuff on it and save it as a PDF within these folders. Sometimes you'll see institution name on it, investigator name. So things like this, probably you don't need for the secondary analysis, so we'll probably just exclude that. Then you get into some more complicated stuff like pixel data, burnt in text. So this is text, but that's in the image itself. So it's not text that's like findable, if you just hit Control F on your keyboard. So you have to do a little bit more interesting searching for it, which is called OCR, optical character recognition, where you're trying to actually identify what's in there. And then once you find it, and say you find patient name embedded into an image or unique subject identifier embedded into an image, we'd want to redact that, either drop a black box on top of it or just remove the whole image by itself. Then we have the re-identifiable facial structures. So this is in an MRI, and we're talking about the defacing. So what I didn't talk about is the way that you actually remove the face is kind of fascinating, and you can look up some of the tools here, but they actually cut the face off of the MRI image. And Anush did a great research into about 14 available tools that are out there, pros and cons of each one of them, and found that this one package that ADNI had also used is probably the best one and that we're recommending to go forward. Interestingly, if it's interesting to you, is actually our MRI reface. So what it does is it takes a normal average face and replaces the face of the participant with the average face. And so that does better things with the cranial structure. And then the last two, file names and folder names, I just mentioned them just for completeness here. So sometimes the folder name or the file name is named the patient number, and you want to make sure that you're grabbing that, you're not releasing that out. So then that would be hashed the same way that it's hashed in the DICOM header, same way it's hashed in the tabular data, to really make sure it's all interconnected and consistent. So you do all this work and you argue about all these different things, and it's way more complicated than I'm making it sound. You get into patient name. You can't actually get rid of patient name in DICOM. It has to be there, so you have to put something else into it, and what do you put into it? There's all these conversations like that. But at the end of the day, what are we doing? The full impact of this, to me, is huge. Because we unlock a whole new data source to be shared with the global research community. From 10 years ago or 12 years ago till now, we've done tabular data. And if we could go from now into the future and we have tabular and imaging data, it's just massive. So I really, I get some goosebumps when I start to think about this. What could we do if there's these data challenges or different things with our images? I think the opportunities are enormous. And then we do this while protecting patient privacy, while maintaining data utility, and this is a balancing act. And this is a balancing act that's going to evolve over time. So while we'll put out what we think is the right answer for our recommendation for imaging anonymization right now, there's no doubt in my mind there'll be a version 2, version 3, version 35 of this as it goes forward. I'm going to acknowledge the 2 members of my team who did a tremendous amount of work on here. Anush is here today. Maddie's on the phone. But we also had great reviewers. Definitely within Biogen, we had our privacy and legal officers look at it. Within Pfizer, they had their imaging experts and data sharing and data anonymization experts look at it. Same with Sanofi. Vivli also was great, helped us move this forward, get everyone together, and bring in some external experts. With that, I'm going to close. We'll see if there are any questions, which I'm very happy to answer as much as I can. I would say, when I did talk to some people, there are people interested in this topic. They have questions. They want to work with us. We're super open to people bringing their comments to us. You can join our working group. Maybe you can reach out to Julie if you'd like to join that. The other thing I'd say is the next hurdle that we're going to have is how do we actually anonymize them? What does the code look like for that? And I'd like to open source a package for that. We have some work that we've done ourselves. Then Boehringer Ingelheim said that they would like to help out with that too. If there are other technical people in the audience or on the phone that would like to help out with that, I feel like that would be another one that would really push us forward. So with that, I'll close, but thank you. Yeah, there's one behind you, but then I can go to you.
Hi. Hi, Dan. Douglas Moore. Are you publishing these guidelines, as a paper, these are best practices?
Yeah, that's a great question. Absolutely. I mean, we want to get this into the public domain as quickly as we can. Really just looking for the best pathway to do so. Right now we're talking to Fuse, see if we can publish it that way. A lot of the tabular imaging, tabular data anonymization stuff has gone out through Fuse, and so I think it could be a good way to get it out there. But if you have any ideas of where it could go in the public domain, I'm happy to hear.
Would love to read the draft.
Yeah, no, absolutely. Let's contact, I can send it to you for sure.
You may have said this in the beginning. Would the imaging data be tied to lab data and or outcomes data?
Yeah, I think I'm referring to that as our tabular data. But oftentimes what people would ask for is our clinical trial, ECRF data, along with that. And so a big part of this is making sure that you don't anonymize both of them separately, right? So they don't match. So you have to anonymize them together.
Because the true value comes in. So what?
Yeah, exactly. Yeah.
So are you treating the brain print as kind of where the state of the art is today on re-identification and that you're not worrying about that? Or do you have specific, mitigations for brain prints?
Yeah, there are even other ones besides brain print that we're just not treating right now. And even when we talk to imaging vendors, not everyone thinks defacing is part of anonymization right now, which was surprising to me too. So I think, even if you went back 20 years, defacing was not normal just because we didn't have the computational power to do it. And now we started talking about it in our working group. We consider it normal, or it needed to happen to be considered anonymized, especially because there's some very direct HIPAA language about the face and the face being a direct identifier. But when HIPAA comes out with brain print being a direct identifier, then we're going to have to rethink. Okay, thank you.